Hi everyone, myself Dr. V. Thrimurthulu, professor in Department of CSC, MLR IT. My subject is Introduction to Artificial Intelligence and today's topic is Informed Search Algorithm. And the overview, the previous videos I covered uninformed search introduction to artificial intelligence, then I covered the uninformed search algorithm. Now today's class is informed search algorithm and heuristic function, search functions, and one of the informed search algorithm I am discussing today's class. In that, algorithm processing steps, advantages, disadvantages, problem solving of the one or two examples, and about the syllabus R22 syllabus MLR IT, today's topic, and a heuristic function, and these are the things I am going to cover in today's video lecture. So there are the two types of search algorithms. One is the uninformed search algorithm, the other one is the informed search algorithm. In uninformed search algorithm, breadth first search, and iterated breadth first search, depth first search, and uniform cost search. These are the things I discussed in last few videos, and today I am going to cover informed search algorithm. So informed search algorithm, what it is some information about the goal state we have, that is just the additional information or heuristic information. That heuristic are called as the additional information about the goal state to make more accurate decisions, so that you can take the decisions and you can explore the path in easy way. These heuristics, what happens, estimate how close a given state to the goal, whatever the present state, how far it is the goal state, you can find out, and it is giving the guidance the search towards the more promising solutions instead of exploring all the necessary nodes. So informed search is particularly useful in solving complex problems efficiently. That is the main advantage, and it can significantly reduce the search space and improve the speed of finding solutions. Improved speed of finding solutions, you can quickly find out the solution. So shortest path you can easily find out with this. Can quickly reject irrelevant or less promising alternatives. In this, instead of exploring all the nodes, instead of exhaustive explorers, now we can unnecessary things, you can irrelevant or unpromising nodes you are not touching. So allowing the search to concentrate on the most reliable options only you are touching, and by employing domain specific knowledge to drive the search. So in this informed search algorithms, greedy based search algorithm, that is one of the thing, A-star algorithm, and graph based search algorithms are there, beam search algorithms, like other algorithms. And today's class, so what is the heuristic search algorithm? So heuristic search is the one kind of strategy used in AI to optimize the search process by using a heuristic function to estimate the cost of a reaching goal, how far it is the goal, you can estimate it. So instead of exhaustively exploring all possible paths in uninformed search algorithms, your time complexity is more there, so that you can reduce it here in informed search algorithm. A heuristic search uses this estimate to prioritize most promising paths, reducing computational complexity and speeding up the decision making. You can get the solution fast. The heuristic function in AI acts as a guide. It acts as a guide providing approximate solutions when exact answers are computationally expensive or unnecessary. And these are the crucial for solving complex problems. This is very much useful, the information about the goal, so that complex problems you can solve it very easily, that involve large search spaces such as path finding, decision making, and optimization. There it is, the heuristic information is very much useful. In these cases, heuristic help narrow down the search space here. Narrow down the search space, so reducing the time, so that what it is, reducing the time complexity is reduced, and the computational power needed to arrive at a solution. Less computational power, you can achieve the goal. So here what it is, the main function is the heuristic function. H of n is the important function, that is heuristic function f of n important, f of n nothing but hn in this case. So hn what it is, it provides an estimate of the cost of the path from a given node, from the current node to the closest goal state. What is the distance, it is giving that information. So must be, and in this case if the goal node you have reached means that should be 0. So must be 0 if the node represents a goal state. If the node represents a goal state, that should be 0. Okay. So these are the heuristic, it is the one kind of strategy. And what are the key features in these cases? It is finding the faster problem solving. That is the one advantage in this case, because it reduces the computational complexity of a problem, and by focusing on most promising solutions. So that what happens, a system to solve problems faster than traditional exhaustive search methods. So that is the advantage in this case. And scalability is the another advantage. This technique you scale well to large search spaces also, it is giving the solution. You can definitely get the destination or goal node. Whether in game playing or robotics or pathfinding, heuristic search can handle large data sets or complex environments also, it can give the solution, making them suitable for real world applications. So scalability is the one of the thing. Then optimal or near optimal solutions you are getting. So heuristic search techniques often provide the optimal or near optimal solutions in a reasonable time frame. So that what happens, balancing efficiency with accuracy also, we are getting the goal node. This makes them highly effective for time sensitive tasks like autonomous navigation, autonomous vehicles, real-time decision making applications. It is very much useful. Then efficiency, another important factor. So in scenarios where finding the exact solution is computationally expensive, so heuristic search techniques offers efficient alternatives by providing approximate solutions that are close to the optimal solution. So these are the key features in this case, heuristic. And in this, one of the best algorithm is the best first search algorithm is one of the algorithm, informed search algorithm or heuristic search algorithm. Informed search algorithm we are also called as a heuristic search algorithm. So one of the algorithm is the best first search algorithm. The name itself is the best first search. So we can find out the best possible solution. So the path that appears to be best at that particular time, present time, is always chosen by the greedy best search algorithm. It is also called as a greedy best search algorithm. You can find out the best node to the destination. It combines the techniques like it is a combination of depth first search algorithm and breadth first search, both the algorithms combination, breadth level or depth level, either way it is going. So both the advantages this algorithm it has. So time complexity is reducing, the other one is the space complexity is reducing. So both the advantages this algorithm. So that's why you are called as a best first search algorithm. And you can benefit from the algorithm's advantages by using the best first search. You can select the most promising node at each stage, at each level. You can find out the best promising node. So using the best first search algorithm, using a stock base, the node that is nearest to the goal node is expanded using the best first search technique, because whatever the best first search technique, that node only you are choosing and you are expanding that one. Then again you are identifying the best node. So like that way you are finding the most promising node only. And the closest cost is calculated using a heuristic function. Using the heuristic function, we can estimate the cost of the destination or goal node. So we can expand the node that is closest to the goal node, and the closest cost is estimated by heuristic function. The heuristic function f of n is equal to the h of n. H of n is the estimated cost from the present node to the goal node, where hn is estimated from node n to the goal node. This is the h of n. So that in best first search algorithm, the function is the heuristic function is the f of n is called h of n. Then what are the steps to perform in this algorithm? The best search algorithm, what is the graph based? It follows the graph by using the priority queue. Using the priority queue and heuristic information, both the based on the heuristic information, you are prioritized the node. So the first node, best node, you are choosing. So it keeps, there have a two lists are there in this best first search algorithm. One is the open list, the other one is the closed list. In open list, what happens? The nodes that need exploring. In open list, whatever the nodes you are going to explore, that information is in open list. And a closed list, those already checked, you are closing. So what you have closed, that information you are keeping in closed list. So how it is operating this process? How it is the process? The first, what it is, the initial node should be, whatever the starting node you are considered as the initial node should first be added to the open list. We are creating the two open list and a closed list. In the open list, first your initial node information, initial node, that is the first node that you are keeping in the open list. Then you are checking that one, whether it is the goal node or not. If it is not a goal node means, then we are moving to the closed list. That initial node is going to the closed list, and then you are expanding that one. Here is step 2, stop and return failure if the open list is empty. If the open list is empty means we are stopping, there is no solution. Move the node n that has the lowest heuristic value, estimated value, out of the open list. What are out of the open list nodes? Which one is the least one, best one, that you are considering as a priority, that you are taking as you are expanding. And in remaining the whatever you are considered, that it is going to the closed list. Then generate the successors. Generate the success of that closed list. Whatever you are going to close, that in keeping in closed list, that successor you are generating all the successive nodes and expand node n. That is the step 4. Once you are expanding that one, successive nodes, then again prioritize all the nodes. Prioritize that one with based on the cost, estimate heuristic value. So then step 5, determine whether or not each successor of node is a goal node or not. You can check it. Return the success. If it is the goal node means return the success and end the search if any successor node is the goal node in that. Otherwise, same step again, move to the step 6. The method examines each successor node for the evaluation function f of n before determining whether it is it has ever been in the open or closed list. Then add the node to the open list. Then if it hasn't already been there means you cannot expand that one. So step return to the step 2. Same process it is going to repeat like this. Then the algorithm how it is working. See, first we are creating the two empty lists. One is the open list, the other one is the closed list. Two empty lists you are creating. Then start from the initial node that you are considering as say n, that is the starting node, and put it in the order open list that you are keeping initially in open list. Then you can check it whether it is the goal node or not. If it is not a goal node means again that initial node, that information is going to the closed list. So repeat the next step until the goal node is reached. Until the goal node is reached, same thing. You are keeping the open list and expanding that one successive nodes. Then prioritizing the things. Then again you are checking the things. If the open list is empty means then exit the loop, returning false. We are not getting the solution like this. Select the first or top node. We are prioritizing so that select the first or top node of the n in the open list and move it to the closed list because that is the prioritized node. Then capture the information of the parent node. What is its parent node also, the information you are keeping in closed list. If n is a goal node, suppose, then move the node to the closed list. Then move the node to the closed list and exit the loop and returning it is true. You are getting the destination node or goal node like this. The solution can be found backtracking the path from the hand to again you are going, then you are getting the path. If n is not the goal node, expand node n to generate the immediate next nodes linked to node n. The successive nodes you can expand it, and all those to the open list, keep it in the open list. And whatever the open list nodes are there, again based on the heuristic function, you can prioritize the queue. So that the first or top node is the again you are considering. So reorder the nodes in the open list in ascending order according to an evaluation or heuristic function f of n. So like this is the algorithm, best search algorithm. So this algorithm will transfer the shortest path first in the queue. The time complexity of the algorithm is the O into n on O number of operation is n into log n. That is the complexity. Suppose can take the one of the example here. Your source is there, and 1, 2, 3, 4 like these nodes are there. And this nodes information, this is the heuristic information is there about the each and every node here. Heuristic information, source node is the 20 to the destination node, it is the 20. Then first node it is the 22. Then 2 is the 21. It's cost, heuristic cost to the destination. 3 is 10. 10 is the cost, estimated cost to the destination. Then 4 is 25, it is 2, and 5 is 24, then 6 is 30, 7 is 5, then 8 is 12. So destination is the 0. This is the heuristic information, and whatever these red numbers, it is the estimated cost, h of n of that estimated cost. So initially what it is, step 1, initialize the two empty lists, open list and closed list. You are initializing. One is the open list, the other one is the closed list. The step 1 what it is, whatever the source SRC, you can open it. What is its heuristic value is the 21, h of n is the 20. That information you are keeping in the open list, first step. Then you can check it whether the source node is the goal node or not. So it is not a goal node. So that what happens again in step 2, it is going to the closed list. So SRC is the closed list. Then you can expand this SRC. When we are expanding source node, what happens? It has a 3 child nodes are there, 1, 2, 3. So that 1, 2, 3, which the heuristic value is the what it is, 1 is 22, 2 is 21, then 3 is the 10. This information now in open list what it is, 3 nodes are there. Out of these 3 nodes, you can prioritize that one as per the ascending order. When you are prioritizing that one, what it is, 3, 2, 1. Like this it is giving 3 value is the 10, 2 is the 21, 1 is the 22. So that what happens now, top node is the, you can check it whether the top node is the goal node or not. It is not a goal node. Whatever the heuristic value, it is the 10. 10 is the destination, so estimated cost. So that you can keep it in information. 3 is keeping to the closed list. Then step 3, again you can expand. Step 3, iterating. Again next iteration what it is, you can expand the 3. You can expand 3 successive nodes. When 3 successive nodes, what it is the 7 and 8 is there. 7 and 8 already heuristic in open list what it is, 1, 2 is there. Now 7 and 8 also it is adding in this open list. Then already you have information, 1 is the 22, 2 is the 21, and 7 is what it is the 5, and 8 is the 12. In this, out of this open list, 5th is the prioritized because that is the least one, that is the best node. So that you can consider 5th. Then that is goal information, you can keep it in closed list. You are keeping in the closed list, 7. Then you can expand 7. When you are expanding 7, the destination you have got it. So 4th step what it is, in 4th step already 1, 2, 8 in already it is there. Now destination is there. Destination is the 0. This information already you have a 12, 21, 1 is the 22. Now already you can prioritize the open list. When you are prioritizing, top is the 0 destination, top is the destination 0, then 8 is the 12 and 2 is the 21, then 1 is 22. So that the top node is this is the 0, that is the best node. Now we are considering the best node and we can check it whether it is the goal node, as it is the goal node, destination node. So that you are closing. When you are closing the destination, then only you are getting the solution. Now there is no information, 0. So that this is the path, this is the path, this is the path to the best path to this problem. Source to 3, 3 to 7, 7 to destination. This is the shortest path. This is the solution for that source to destination. Okay. So this is the one of the example. Yeah. The other example also it is there. You can find out another example. Suppose this is the source. This is the other nodes are there, and whatever the heuristic values, your node information is there. Whatever the estimated source is the 10 like this it is there, and A is equal 9 and B is equal 7 the other problem, and C is equal to 8 like this it is there. Then D also it is the 8 and E is equal to 0, then F is equal to 6, then G is equal to 3, H is equal to 6. These are the nodes. Now we can find out from this source to goal node. E is goal node. E is the goal node. You can find out the path. E is the goal node. You can find out the path. So we are to empty list, open list and closed list. In empty list, what it is? You are keeping S value. S is the empty open list. S is equal to 10. That information. Then second step, what it is? Now you can S is going to the closed list in second step. Then whatever the S successive nodes, child nodes A, B, C is there. Then A, B, C information you are keeping in that nodes you are keeping in open list. After the second step, what it is? You can prioritize all those things. When you are prioritizing, what it is? B, C, A. B is the top one. So that is the least node, that is the best node. Then second step is that is the you are prioritizing. Then third step, what it is? That prioritized node you are considering. That prioritized node you are considering that one. You can consider this one B. It is going to the closed list, and you are expanding B successive nodes. You are expanding related to B. You are B related to B. What it is? D is there and H is there. So that you are expanding that one. See, D and H instead of B. What happened? B is the least one in that step 2. D and H you are adding. Then again prioritize that one. So when you are prioritizing that one, what it is? This is the harder. So H is the least one best node. You are considering the H is the best node. First source, then B, then you are considering the H. When you are considering the H, what it is? You can expand whether the H is the goal node or not. If it is not goal node, means you can it is coming to the closed list. That it is coming to the closed list here. Coming to the closed list, you can expand H. When you are expanding H, what it is? G is there. So G is there. So that G information you are keeping in here. So like that way you are solving the problem. So you are keeping the open list, then prioritizing the things, then finding the top node is the best node, then whether it is the goal node or not. Otherwise you are keeping into the closed list, moving to the closed list, then you are expanding that node, child nodes. Like that way you are solving the problem. You are getting the optimal path or near optimal path. Optimal path you are getting. So what are the advantages and disadvantages in this case? The advantages, it is the simple and easy to implement. That is the one thing, because it is the advantage of both the breadth first search and depth first search. So the simple and easy to implement. It is the fast and efficient algorithm, especially with the good heuristic. If the heuristic value is the good, estimated value is the exact, means we will get it is the very fast and efficient one. Low memory requirements. The space requirements is very less, low memory requirements. And it is more flexible and adaptable to different problems. Definitely will get this goal node. That is the case in this best first search. What are the disadvantages in this? Not guaranteed to find the optimal solution. So we will get the near optimal solution, not exactly optimal solution. That is the one drawback. Can get stuck in local optima. If it is the local optima is there itself we are stuck in. That is the problem is there. Requires a heuristic function adding complexity. When you need the heuristic function based on that you are prioritizing so that some more complexity, computational cost is more. Not a complete algorithm may not find the solution in complex search spaces. Complex large search spaces may not get the solution. That problem is there with the best first search algorithm. So what are the applications in this case? Greedy best search is used to various applications here. Pathfinding purpose, that is the main thing in video games, robotics or navigation systems. So machine learning algorithms to find the promising path. Optimization of system parameters. You can optimize the system parameters. Network routing optimization, you can do it. Game AI for evaluating potential moves. So you can use in a NLP task, natural language processing like language translation or speech recognition. There also you can use it. This best first search algorithm. These are the advantages, disadvantages and applications of the best first search algorithm. So today video I covered the informed search algorithm, what it is, heuristic function I discussed, best first search algorithm I have discussed. This is one of the best algorithm to get the optimal or near optimal solution. So what are the algorithm processing steps and the algorithm of it is, and what are the disadvantages, the advantages I discussed here, and problem solving also, or 2 examples I discussed in this video. Any queries, please mail me. Thank you one and all. And my next video covers hill climbing algorithm and what are the different types of hill climbing algorithms I am going to discuss in next video. And state space diagram I will explain, and a pseudocode of the hill climbing algorithm, advantages, disadvantages of the hill climbing algorithms I am going to cover in next video. Thank you one and all.